The tradition of industrial engineering began with the idea of creating standard work. That was what Frederick Taylor was doing in the Principles of Scientific Management, and Frank and Lillian Gilbreth were doing as they were studying how to decompose jobs into ever smaller, bite-sized chunks that could then be created as standard movements. What we see is standard work is a process that gives a detailed definition of the most efficient method to produce a product or perform a service, and a balanced flow of work to create a desired output rate or deliverable. If the process, it's going to break down work into elements. They're going to be sequenced, organized, and repeatedly followed. So standardized work should be able to deliver repetitive results. So workers need to be trained in those things. They have to be given the tools and methods necessary to do that work, equipment that performs those tasks. They have to be thought through in terms of decision rights about how you make choices in the execution of that standard work, and how indeed we're going to maintain this cycle time so that it's going to be reflecting the demand on the system for output capacity of volume of the deliverables as well as the quality. And then also, what are the standards for performance of the work that's in the process of performance? And we see that in analyzing these things, Taiichi Ono made the comment that impressive standard work is never absolute in practice. In other words, it's always changing. It's always improving. And we start taking a look at this in the Toyota system. We see that there's a number of things. They take a look at what is the production capacity sheet. What is the volume, in other words? So they have a process, a documented, if you will, work analysis to figure out how do we manage the volume. Then they have a standard work combination sheet. How do we put the standardized work in place across that production capacity to be able to deliver this in the work processes? And then at each task level, there's a standardized work chart. Now, when we talk about this, we want those instructions to be written by the workers. And those instructions have to be written in a way that is credible. In other words, it has to be consistent with the training that they have. There has to be consistent with the instructors that the workers receive from supervisors. And workers have to trust that those instructions are right, that they're current, and they describe what they should be doing. So they have to be credible. They also have to be usable. They have to be clear. So workers need to understand them. One of the things, and I think many organizations do who actually create really good work instructions, have very little text. They have a lot of graphics or photographs. And when there is text, it's ideally written in the language of the workers so that they understand it, both the speaking language of the workers as well as the usage of the words. So if I, as a graduate industrial engineer, write what a worker needs to do and they haven't had a high school education, they can get lost very quickly. Another characteristic of work instructions is they need to be accessible. They have to be readily at hand so a worker in mere seconds can easily retrieve the knowledge and remind themselves of what they need to do. Ideally, it should be displayed as a job aid at the workstation in full sight of the worker and be done in one page. The final element of a work instruction is that it should be consistent. So it should match the training of the workers, and it should be used every place that that particular task is being done. So a work instruction is developed typically by a team of people who are doing the work. And it's an output, if you will, of our Six Sigma Green Belt project. So if in the Green Belt project you've had workers engaged in helping you to gather data, analyze data, and interpret it, then what you should do is have a meeting with those workers and hand off the responsibility for ownership of creating the work instruction to them, where you act as a facilitator or a person who is engaging the workers and helping them through the process. But at the end of the day, the workers should look at that work instruction and say, we've got our fingerprints on it. It's actually doing the things we need it to do. And that work documentation should be right-sized. It should be at the level, the minimum level of performance. Not hundreds of pages, ideally one page per job, and if necessary, maybe a couple of pages, but certainly something that they can then use hands-off and not have to study to understand what needs to be done. This should be then approved by the process owners. So the process owners are saying, we've aligned all of these work instructions for the individual jobs so the flow will go properly. I won't turn it into a spaghetti bowl mix of uneven flows and mora and muda in the process. And so no more than 8 pages in terms of a procedure. So the procedure is the combination of the work instructors across a particular set of processes. And in that sort of thing, what we need to do is align the work. We need to, it's a terrible word, but institutionalize. And that means that we can make sure that the people who are doing the process understand this is our best way of doing it. So if the individual has an idea something can indeed be done better, that they will come back and make the suggestion to the supervisor. The supervisor will then monitor the experiment, and then the one best way of doing things, as documented in the work instruction, can be improved. But we shouldn't allow everybody the democratic execution of a work process. I do it my way because this is me and I want to do it that way. And then what we soon see is a breakdown of standard work where everybody's doing what they want to and there's no cross-functional coordination. Many of the tools that you've used are actionable and helping in terms of creating job aids. So some of the job aids may be the plant layout diagram. Maybe it's a spaghetti map and we see what people were actually doing, the process control chart, or the cross-functional flow chart, which we call a deployment diagram, or they call in Visio the swim lanes document. Or maybe we take a look at the waste in the process by process step with the ANOVA and the Yamazumi diagram. Maybe we take a look at the structured work breakdown where we take a task and break it down in each of the very small physical components. Or we have the standard operating procedure and work instructions. And those are the documents that say this is what we're doing across the process, the procedure, or within each step, the work instructions. And maybe we have the work audit. How is the supervisor going to know and check, is this work actually being done? Maintenance systems have to be done. How do we actually routinely keep up the equipment that's being used in a process? That's even true in a service process, where we have to make sure that the service process is being kept up in terms of software, in terms of the computer hardware that's supporting the recording of those transaction events. And then how do we monitor that process in terms of taking a look at the reporting and the measurement systems? So many things will go into this. As industrial engineers, you may study ergonomics. And so the understanding of that job task in terms of economy of motion is one of the things that can be studied. Another is the equipment layout. How do we actually reduce the amount of flow distance traveled in terms of the way we've laid out equipment? Do we have good lighting, both general and task lighting? Have we got the racks assigned properly so that they actually present the equipment and the parts to the workers in the best way? Do we use either straight lines or U-shaped cells based on the flow and the types of tasks that are being done? Do we have tools and jigs that actually help the workers get the parts put together or the service components done right and assembled in a way that gets the job done properly whenever possible? And then finally, how do we get the workers engaged in activities to continually improve the process? So these are the quality circles, or the quality circle, Kaizen quality circle activities. And so what we see is the idea is what we want at that work level is we want to provide 100 hands and 100 minutes to work on improving work with a highly multiplier effect. If we have 100 workers and they have 100 set of hands and we have 100 minds working together and they're using different ideas, basic quality tools, things we might call yellow belt training, then we can recognize their ideas and they have an opportunity then to say, all of the things I've been doing, it comes to me there's a better way to do this. And so building on this is actually the fundamental of creating a standard process. And then once we get that standard process, we have to have standard training. So this is the training within industry approach that was done in the very beginning of the Toyota production system, which is still fundamental to the idea of preparing a worker to work in that type of system. Well, if it seems like there's a lot to do in terms of standard work and getting the process, there is. And it's the discipline of following that approach and making sure it's done properly that creates the quality output on a rigorous basis and allows us to know we're having a problem, we need to do something about it, and here is where we should pay attention to making improvement. And also, here are the people that can help it. So, standardized work is one of the most fundamental things we would like to get out of the end of our control process. Because once we've got that standard work, we have the checks and balances in place to do it, then we can continue looking for other opportunities for improvement.